Hi everyone, today we're going to talk about refraction and Snell's law. Now this is the phenomenon where when a ray of light comes in and changes the medium it goes into, such as for example going into water or glass, the angle that the ray makes changes. So the ray appears to bend. And in this case, if we draw a normal in, the ray would normally continue that way and we should see, hopefully, it come through there. As it comes out, you see the reverse approach. It comes back to being parallel with the original ray. Now we want to investigate this and find out just how much it bends. To do that, the best thing to use is a ray box and a nice clear plastic prism. However, you're not likely to have that if you're at home, so I've just organised a little bit of a cheat. You can also do that with any old torch that you've got. You could use the torch in your phone. You need a little bit of cardboard and you just want to cut a very thin slit, as small as you can, and then a plastic ruler. And I'll set this up and I'll show you what that looks like in a moment. Okay everyone, so we've now got our equipment handy. Easiest thing to do is to set up a normal, so you can see my block here. What I'm going to do is I'm simply going to put my block down and I'm going to draw around it. I'm going to try to line this up so it looks like it's as straight as possible. Now it doesn't have to be absolutely perfect. I'm then going to put a tick mark where the ray comes in, over here where the ray comes out, and over here, and I'll label those 1, 1, and 1. My next trick is I'm going to move the ray box around a bit. So I'm going to bring it around. I'm going to try to aim it at the same point. Now, when we look at this, we can see a few interesting things. Number one, we can see a reflected ray coming off here. I'm going to put that mark there so we can see where it comes in. Now, if I were to continue the ray straight through, let's put a ruler on top of this. You can see that it's parallel to this ray over here, but it isn't quite on top of it. Through here, you can see that it has a different angle. So let's mark the end point of that one. 2, 2. And we'll try a few more angles. So let's try about there. A nice steep angle, probably around about 50 degrees. There's 3. There's 3. And there's 3. Notice every time I'm trying to make it hit that same point on my original diagram. Okay, I'd continue that through until I have a range from about 0 degrees to about 90 degrees, 5 or 6 measurements in total. Don't forget that every one of those angles is actually measured from the normal. So let's put a normal in. We'll grab our ruler. We'll get it to be as close as possible to perpendicular. There's our normal. And we'll put a dashed line to make it easier to see the outside. So on this one, keep it nice and big. Join the dots. Join the dots. And join the dots. And it's always a good thing to remember that as it comes out, it should be parallel to the original ray. So those two are parallel. The angles that I'm interested in, I don't care about where it comes out at this stage. I'm interested in this angle here, which is my angle of refraction, and this angle here, which is my angle of incidence. And I'm going to record all of those in a table and then see if I can work out what the relationship is between them. Now, if you're at home, you're not going to have the nice toys. So what we're going to do, I'll turn that off. I've gone really high tech and I have cut just a tiny little slit in a piece of cardboard. I want to keep that as thin as I can. I could possibly go a bit thinner than that again. This will do. Now I'm not going to bother with a new piece of paper, this is just a demonstration. For my prism, I don't have a lovely piece of plastic at home. I do have a clear ruler. You could also use a piece of glass. Try to keep the edges straight and parallel, otherwise it gets awkward. Finally, I've got a torch. Now I could do this with my phone, but I happen to have one here. You can see this is not the best slit in the world. It is slightly divergent, and it is not a perfect thing. However, it does do the job. So I can then look at this and I can say, right, here's my ruler. And I will again start by drawing my parallels. I'm going to aim it at a point as perpendicular as possible. So I'm going to mark that as my point, as my point. Now what you can see here, this ray is much wider, but that's okay. So let's come across to about here and we'll aim it there. Now this is where it gets a bit tricky. You can see the ray kind of coming through here, but what's important is if I take the midpoint of this one, which is just there, as I join that line there, it's at a different angle to this one. It then continues through. And although it's not as nice as using the real thing, you should be able to get to within a degree or two. And look, we're going to do the best we can. So here's my next one to there, and it comes out there. I'll put a 3 on that so I remember which one it is. And off it goes. So I care about that. I can do this to work it out. Okay, so what you're going to do, exactly the same thing. Draw about 6 rays, starting from parallel to the normal, so you actually have a 0 angle of incidence, through to as close to 90 as you reasonably can. Now for that, you may need to aim at a point down here. The ruler is going to be easier for that. You're then going to record all those in a table and do a graph of the angle of refraction against the angle of incidence.